So what we're going to do today is we're going to be solving systems of equations, but we're going to be using substitution in order to solve these. Now, if you remember what substitution is, it's where you take a number and put it in place of a variable, and now you solve however you need, right? Well, that's basically what we're going to be doing here, except now we have two equations that we're going to be doing this with, right? We have this equation and we have this equation, and we're still looking for where are both of these true. That's what you're looking for. So what you're going to do is you're going to take one equation and substitute it actually into the other one. Now, we do this because look, we solve for one variable. We get one variable isolated. And here, where both of them are solved for y, so they both have y isolated. You're going to take what y equals, the 2x minus 5, you're going to take this and substitute it in for y, because what we're saying is, hey, y equals this. Okay, if y equals this, I can take this whole part and substitute it in for my y over here. Right? So that's what we're looking at. So 2x minus 5 equals 3x minus 34. And now what we can do is now we can start to isolate the x, right? And you've seen this where you have variables on both sides and you solve down for the one variable. I know because I taught it in pre-algebra. You've seen it, okay? So we're going to solve for x. Well, in order to do that, we get the x all by itself. So we're going to start moving things away from our variable. Right? That's going to get rid of this, right? And it leaves us with the 3x over here, and it leaves us with 2x plus 29, right? So far, so good. But now we need to get our variables together, all right? Well, and then 2x, okay? This cancels out and leaves us with 29 equals, and 3x plus negative 2x gets us 1x or x. So the first part is x equals 29. All right, so our solution for this, first off, is an ordered pair where x equals 29. So we're going to take the 29 now, and now we're going to substitute it back in to one of these. And it doesn't matter which one. And that's the nice thing about this. I can actually pick which one I want. So I'm going to take the 29 and just plug it into this one. It looks like it's the simpler one to deal with. So y equals 2 times 29 minus 5. Okay? Well, y equals 58 minus 5. And 58 minus 5 is y equals 53. So now, my ordered pair where these two lines cross and they're both true is 29, 53. And if you really want to check these, take these, substitute them into both the x and the y, and make sure they're both true statements. If they're both true statements, you've got a good solution. Okay? So that's what we're doing. Okay? Solving systems of equations through substitution. We're taking one, substituting into the other, solving so that you can see where those two lines intersect. That's what we're doing. All right? Y equals negative 3x plus 1, and 2x plus y equals 1. Again, notice, when it's in slope-intercept form, it's already solved for your y. So just take that and substitute it into the other one. All right? So 2x plus, and I'm going to take this whole part and substitute it in for y. So negative 3x plus 1 equals 1. And then I'm going to start solving, okay? Well, 2x plus negative 3x gets us negative x plus 1 equals 1. Now I'm going to move the 1 over. Okay? And in case you're wondering, I'm adding the inverse. So I've got negative x equals 1 plus negative 1 is 0, and even if I take the opposite of x, it's still 0, right? So x equals 0. Now I'm going to take that 0 and I'm going to substitute it in. And I'm going to, again, I'm gonna pick the easier of the two, but in this case, it really doesn't matter. Okay, so here, we'll do this one. Y equals -3 times 0 plus 1. Y equals 0 plus 1. So y equals 1. And all I did was the multiplication, the addition, and there you have it. So our ordered pair, x equals 0, y equals 1. There's where these two lines cross, and they're both true. That's what you're looking for. Okay? That's what you're looking for. All right. Same thing over here. 5x minus y equals 5. Negative x plus 3y equals 13. Now notice, neither one of these is solved for one of the variables. They're not in slope-intercept form. So now what you need to do is look at your equations here and choose one to put into slope-intercept form. Now, on this one, it does matter because one is much easier than the other. Okay? When I looked at this one, this was the first one my instinct said to go to, but when I started looking at it, I knew I was going to add x to both sides, but then I'm going to divide by this 3 here. And that's going to give me an ugly fraction at the end. And I don't want to deal with that ugly fraction. So I don't want to use this one. I'm going to come over here and I'm going to use this one. And I'm going to change it to slope-intercept form so that I can substitute it in to this equation. Okay, so here, I'm going to take right here, we're going to add the inverse here. Okay, leaves me with negative y equals negative 5x plus 5. But I want the opposite of this, right? So I'm going to go in here and I'm going to change it. So I'm going to multiply everything times negative 1. So negative 1 times negative y gets me y. Negative 1 times negative 5x gets me 5x. Negative 1 times 5 gets me negative 5. Or you could have minus 5 there. Same thing. Okay? Now I'm going to take this and substitute it into this. Okay? So, and it's going to go in for the y. Now watch this because this is important, right? I've got negative x plus 3. The 3's still there and it's getting multiplied times whatever y is. So 3 times all of this. So this goes in parentheses. 5x plus negative 5, parentheses, equals 13. Very important step. Don't mess that up. Okay? Now I'm going to use my distributive property here in order to get rid of that so that I can start combining my like terms. Okay, so negative x plus 15x plus negative 15 equals 13. Now we combine our like terms all on one side. 15x minus x, 14x plus negative 15 equals 13. Now I'm going to start moving things over. Add 15, add 15, okay? That gets rid of that. Leaves me with 14x equals 28. That's much cleaner than what I would have got if I'd had to do that. Divide by 14, divide by 14, crosses out, x equals 2. Okay, so now we have our x. Again, we want our ordered pair, 2, comma. Now I'm going to take this 2, and I'm going to substitute it back in, right? Now I can substitute it back into this, but I've already got it solved for y here. So I'm actually going to take it into this. Now be careful with this because if you didn't solve this correctly, it's going to cause you problems, all right? But that's what I'm going to do because this is going to give me the easier answer, right? Y equals 2 times 5, so 5 times 2 is 10, plus negative 5, still y equals 10 plus negative 5, y equals 5. So where these two lines cross is at 2, 5, and now we have the solution for these, okay? One solution, one solution, one solution, no problem, just had to solve. Be careful of which one you use, okay? Watch those, because that would have been really ugly to deal with. If you get it and it's ugly, go to the other one, solve that one, okay? Doesn't have to be ugly. All right, so now we have x equals y minus 1 and negative x plus y equals negative 1. Now look, this is already solved for x. X is by itself. So let's use this that they've already given us, and let's take this and substitute it into this. Okay, so we're going to take this negative 1 y minus, we're going to take this y minus 1 and substitute it into the x. But notice the negative here. Okay, what that means is that it's negative, the opposite of all of this. So when I substitute it in, the opposite of y minus 1 plus y equals negative 1. See how that works? So I want the opposite of all of this. So this distributes through here. This changes all the signs in there. So distributes here, negative y plus 1 plus y equals negative 1. Now watch what happens here. We combine our like terms. Negative y plus y. Well, that gets us 0y. Okay, so that eliminates these, right? That leaves us with 1 equals negative 1. And notice, this is an untrue statement. 1 does not equal negative 1. This is no solution. No solution. I got an untrue statement here when I solve this. Okay, so this has no solution. Now, what does that mean for us? Well, that means that these two lines are parallel to each other and they're never going to cross. Okay, that's what that means. Okay, all right. Negative 1 equals 2x minus y. 8x minus 4y equals negative 4. All right, so we just need to solve for y on one of these. Okay, put one of them into slope-intercept form. And honestly, it doesn't matter which one you do. I always just pick the easy one. Okay, so let's do that one. All right, negative 1 equals 2x minus y. We're going to move things over, right? Plus negative 2x plus negative 2x gets us negative 2x minus 1 equals negative y. All right, so two things I'm going to do here. One, I'm going to switch it because I don't like that form when I have the slope-intercept form. So negative y equals negative 2x minus 1. Now this is a step you don't have to take. This is something I do for me. Okay? Now, I got the opposite of negative 1, so I'm going to multiply everything on both sides by negative 1 so that this is a positive y. So this becomes y equals, okay, negative 1 times negative 2x becomes 2x. Negative 1 times negative 1 becomes plus 1. Now I'm going to take this and substitute back in. Okay, so this will go right in here. So 8x minus 4 parentheses 2x plus 1 equals negative 4. Now again, remember, this has to get distributed all the way through here, but this right here goes with this 4. Okay, so we're going to come in here and do click, click, plus negative 4. And we're going to distribute this negative 4 all the way through. So you end up with this, 8x plus negative 4 times 2x and negative 4 times 1. That gets you negative 8x plus negative 4 equals negative 4. Now, 8x plus negative 8x, that gets you 0x, and 0 times x is 0. So you end up with a 0 plus negative 4 equals negative 4, which ends up with negative 4 equals negative 4. Ah, we have a true statement here. Negative 4 equals negative 4. That means that these two lines are the same line. They're on top of each other, right? They're the exact same line, which means we have infinite solutions on this, okay? We have this and this are the same lines, okay? Infinite solution. So we had infinite solution, we had no solution, and then we had several with one solution, okay? Pay attention to it, okay? Consistent, one solutions are consistent, no solution, inconsistent, okay? So make sure all right, so that's what we're looking at, okay? Make sure you recognize it when you see it, right? Infinite solution, okay? No solution, this is the inconsistent one, the rest of these are consistent, right? No solution, one solution, and watch the distributing of that. These are the key areas where we make our mistakes, right? Watch the distributing, I mean, that's really all there is when you're using substitution in order to solve systems of equations. If you have any questions, let me know.